Hello everybody, welcome back. So in last lecture we talked about the and we stopped at the system concept, and we were short, we very quickly discussed about the isolated system and the closed system. Okay. So today we will talk about the open system further. So very quickly going back again to those slides and then move ahead. Okay. So we isolated system, the boundaries completely prevents the exchange of either matter or energy. Okay. Whereas in the second one, that is the closed concept or the closed system, we are having the no exchange of matter, but the boundaries will exchange or will allow to exchange the energy. Okay. So this is what I was talking about, that if we are having the radiation coming in, then we can say that okay fine, there is an exchange of energy, but there is no exchange of matter in terms of this thing. So this is the best example which explains about the which we also call the greenhouse. Okay. So we are having the short waves, okay, radiation coming in, and we have the greenhouse, what we call the glass, okay, which is very much similar to the troposphere. So the shorter waves are coming in, and then we are having some of the radiation, okay, that is what some of the long wave radiation is transmitted back to the atmosphere, and some is reflected back again to the earth surface. Okay. So that is what we are, which cannot pass through the glass, okay, and that is what is very much similar to your atmosphere. So we are having the sun short waves coming in, there is a radiation, okay, and then we are having the infrared, which are radiated back to the ground, which are not transmitted into the atmosphere, whereas some of the long waves, okay, or the radiations which are transmitted into the atmosphere, and very much similar to what we are looking at here, okay, that we are having the water vapors and the carbon dioxide, which acts as a glass, very much similar to what we have seen here, okay, which does not allow or partially allow the radiation to move into the atmosphere. Okay. So in that sense, if you look at this, and then if you consider what we talked about in the previous slide about the closed system, okay, then this fits into the closed system. But let us move to the last one. This is an open system. Okay. What happens here? Okay. So if you are throwing some material or the matter into the beaker, what we have been shown here, then you are in turn you are exchanging some material, that is the water has been poured out, okay, but the radiation is there. So you have the energy coming in, you have the energy here, but you are pouring it out actually here. So not only the energy, but also the matter has been exchanged. Okay. So earth is only approximately a closed system. It is not a completely closed system, but it is approximately a closed system, and the reason is because of the impacts of meteorites, what we see. Okay. So because the meteorites coming from the space, okay, and fall on the earth's surface causes slight escape of gases into the space. Okay. So some gases are been escaping into the space, but in the closed system this was not happening. Okay. So we can say that earth is a more or less approximately closed system. It is not completely closed system. Okay. But if you look at the internal 4 systems of the earth, then those 4 systems are totally open systems. Okay. Let us see those one. So earth system, what we are having, so we have seen that the earth system is a partially closed system, but within earth we are having the other systems which are open. Okay. So earth system is composed of one geosphere, which is mostly made up of rocks, okay, then atmosphere, air and gases on what we call, okay, and then we are having the hydrosphere made up of water or comprised of water, then we are having biosphere, which comprises life in all its form. Okay. So energy and material like water, carbon and minerals, okay, are transformed from one system to another, hence they are open system. Okay. They are not closed system. Okay. So, to a close approximation, Earth is a closed system, but not a completely closed one. Okay. So, open system, this we have already talked about. So, this is an open system, can exchange both energy and matter across the boundary. Okay. Now, for example, why we call this as an open system? Because it can exchange both energy that is coming from the sunlight and the matter across its boundary. Okay. That is, for example, the drainage basins are internal, which can exchange the sediments and the precipitations coming in. Okay. Hence, we call this as an open system. Okay. This is not an closed system, but global hydrological cycle, if we take in terms, okay, it is a closed system. It is not an open, but the hydrological cycle within the system of the Earth, if we look at, okay, we are having what we see is an open system. Okay, because it has input and output, gets energy from sun and precipitation, that is what we see in the form of rain and snow. It enters the system and water leaves the system. Okay. Hence, there is an exchange, and we call this as an open system. So, with this we have already talked, so I will just move ahead. So, now what is, we are looking at the geosphere mainly. Okay. The geosphere, it comprises the Earth's core, mantle. So, this is the interior of Earth we are talking about, and crust. Okay. Crust is the top layer of the Earth, and then we are having the continents, that is the crust comprised of continents and ocean floors, mountains, rocks, sand, dust, metals and all that. Okay. And then we are having the hydrosphere, mainly comprised of water, okay, which comprises ocean, lakes, rivers, groundwater, glaciers, polar ice caps, rains and snow. Okay. And then we are having the atmosphere, we have the gases, okay, oxygen, nitrogen, water vapor, ozone and wind. And then we are having the biosphere, which is what we call it comprises of life. Okay. It's plants, humans, animals, insects and microbes. So, Earth's environmental system. Okay. Now, this is very much important. Okay. What we have looked at, like we are looking at the biosphere, we are looking at the geosphere, we are looking at atmosphere, hydrosphere and biosphere. Now, in short, all this are linked. Okay. What I mean to say is that if you disturb one, the another will be affected. Okay. And that is what happening nowadays. What we are talking about, the greenhouse effect, or we are talking about that we are pouring more of carbon dioxide in atmosphere and all that, and we are forcefully trying to change or the climate. Okay. So, we are moving towards the hotter climatic conditions. Okay. We are melting the polar ice and all that. Okay. So, those things are extremely important. So, they are what we call is they are interlinked. Okay. So, all systems, okay, are interlinked with one another. So, if you disturb one, the another will be affected. Okay. So, human influence. Okay. What is the human influence we are looking at? Okay. We humans are influencing Earth's external geological process. Okay. We are not capable of doing something to change the internal process. Okay. But we are influencing the external geological processes. Now, we are more than 6 billion people. Okay. So, the population has gone up, okay, extremely high, and we are disturbing the. So, what we have done is we have overloaded the system. Okay. So, we can move with the normal this thing, but we have overloaded. Okay. So, we are moving in an overloaded fashion. Okay. And we are disturbing the climate, influencing the either the biosphere or geosphere or hydrosphere. Okay. Now, our daily activities, if you take, okay, we are surrounded by many of such processes, and we should know about it. Okay. So, on the daily activities are having measurable effect on this. Okay. What will be affected is the rainfall. Okay. So, we have seen that nowadays we are having very erratic rainfalls and all that. Okay. we are moving towards the hotter climatic conditions, then we are having more of air pollution, okay, by influencing or putting in. We are deteriorating the water qualities, okay, by either adding the toxic elements or we are not improper waste disposal if we are doing. So, we are also affecting or influencing the water quality. Of course, we are resulting into the erosion. Okay. So, very simple, we can talk about that. If you are cutting the trees, okay, you are exposing the earth surface to erosion. So, we are having more of erosion and all that. Okay. So, if you look at, you can say that, okay, fine, we have affected more. Yes, of course, the rain cycles and all that we are doing, okay, then this may affect, resulting into the floodings in the region, okay, floods, and thus, okay, we are moving towards the hotter climates. Okay. So, we are having the hotter climate, of course, the pollution of air is there and all that. Okay. So, you can remember this, what happened in Delhi recently, that the people were being forced to move less or put less vehicles on the road, and we came up with an odd and even. Okay. And then water quality, of course, we keep on crying about that the poor water quality, that is mostly we are talking about the groundwater. Okay. And then we are talking about the erosion in the hilly areas. Okay. Fine. So, this we all know that there is a considerable effect on our because of our daily activities on the geosystem, or maybe you can talk about the earth processes. Okay. But these are all external processes, not the internal. Okay. Now, to have proper understanding of earth processes, it is essential to understand the natural processes, that what we call the geological processes, mainly related to earth and its environment. Okay. As I told in the beginning, that all these systems what we are looking at, okay, either it is biosphere or geosphere, atmosphere or hydrosphere, they are interlinked. Okay. So, we need to know and understand the natural processes related to earth and its environment. So, we will talk about the internal processes, and we will go as we move in this course, slowly we will talk about the internal processes, plate tectonics and all that, and then we will talk about the external processes. Okay. So, geology and geological processes, if we look at, okay, so then in short, what is geology? If we define very short, geology is the science of earth. Okay. And we study the earth's processes such as volcanism, glaciation, stream flow, rock formation. Okay. So, here we will be talking about the volcanism, we will talk about the stream flows, and we will talk about the rock formations. Okay. This is a picture of Fujiyama from Japan, and then we will also try to understand that the chemistry of the earth material. Okay. So, we see those very beautiful rock crystals, okay, or the minerals which we are looking at here. Okay. One is the diamond, then we are having rock crystal, and then we are having the ruby. So, to understand the minerals, okay, dissolved minerals, and then we can also talk about the mineral resources, which is extremely important for our Indian subcontinent, or for our country, and then of course, we will talk about the rock formations, okay, and then groundwater. Now, geologists mostly try to study and understand the physics, okay, of the earth to know the plate tectonics, then talks about the volcanism, then earthquakes mainly, landslides, and then biology. If you want to understand, then you talk about that how life process is integrated with other earth system, okay, and then how life has evolved. And the fossils and the rocks, they try to look at and to understand that how the things evolved over the time. Then we also talk about, we need to know the drainage system on the earth's surface. Okay. So, you need to understand the meteorology, stream flow, groundwater levels, okay, and then if you go to the oceanography to understand the sea floor roles in plate tectonics. Okay. shorelines, how they have changed, how they have modified over the time, okay. And what do earth scientists do mainly? Okay. They seek to understand all the processes that operates on and inside, that is the internal and external processes, okay, within the earth. Okay. They study mainly like our planet long history, how it evolved and all that, come up with a lot of theories and postulations that how the planet was evolved. Then we talk about the rivers and lakes, water bodies mainly, then hazardous processes such as earthquakes, tsunamis and all that, volcanic eruptions, floods and landslides, rocks they talk about, and the spot surface patterns. Okay. So they too look at with the help of remote sensing, they try to study the surface process or surface morphology. They also use, this is just an example to give, but usually the earth scientists, they use different type of geophysical techniques to understand or they penetrate the subsurface and try to understand the subsurface material and as well as the morphology. Okay. So they try to look at the physical versus historical geology. Okay. So chronology of the events, because as I told that there are particular period where there was an extinction, for example, of like in Jurassic we talk about the extinction of dinosaurs and all that. So what was that event? Why that species got extinct? Okay, it was because of the massive volcanic eruptions. Okay, so whether there was some events which resulted into the drastic or affected the species or it got extinct. Okay, so those can be studied and the chronological order can be built up in that term. Okay, so the past is the biggest clue to the present. Okay, so we usually try to understand the past. Okay, what happened in the past and whether similar pattern will be repeated in future. So that we can predict. Okay, then we have the physical geology. Okay, concerned with the understanding of the process of the material. Okay. So now in total what we have discussed, if we look at the earth as a whole as a system. Okay, so earth system, if you look at, you have the cryosphere, you have atmosphere, hydrosphere and biosphere here. Okay, and which involves that mainly deals with the climate system. Okay, and then we are having the inner side. Okay, what we are having the plate tectonics. So we are having climate system which exists over the surface, or we can say the external process, and this is an internal process what we are having the plate tectonics. Okay, which involves the interaction amongst the lithosphere, asthenosphere. This details I will talk when we are talking about the internal of earth. So what is the asthenosphere and what is your the deep mantle and the core and all that. Okay, but in short this all are been linked. Okay, so that what we call as an the interlinked system between one another. Okay. Now what we will do is we will go to the another topic. Okay, and that is what we are going to talk about the plate tectonics. Okay. So before we get into the part of the plate tectonics, we will talk about or discuss about the internal structure of the earth. Okay, and then we can move and talk about the plate tectonics part, because if you are not having the understanding of the internal structure of the earth, then we won't be able to understand the processes, that is the plate tectonic process. Okay. So internal, as we discussed very briefly that the interior of earth is not a homogeneous. Okay, it is not homogeneous, it is having different layers. Okay. So we have like core, we have mantle, and then we have crust. Okay, these are the broader classification of the earth. Okay, now this is in very much detail. Okay, which talks about and how. Of course, when we will be talking about when the interior of the interior of earth and the seismic waves and all that. We will talk about that, how the seismic waves helped in knowing the variation of the material or the boundaries of different layers within the earth surface. Okay. So, whatever we have marked, for example, if we are looking at from the surface, okay, we are having the oceanic crust and we are having the continental crust. Okay. So, these are the two, the crust we are having, and this forms the lithosphere. Okay. So, this we are having the lithosphere, which is comprised of oceanic crust and the continental crust, and its thickness is very meager in terms of, because if you look at the total radius of the earth, okay, we are having almost like 6,370 kilometers. Okay. So, we are having very thin portion of the earth layer, that is your lithosphere, okay, and that is comprised of your continental crust and the oceanic crust. So, if you look at the details here, you may refer when you are giving the slides. Okay. So, what we are having here is that we have the oceanic crust, the thickness is almost like 5 to 8 kilometers, and the thickness of the crust, that is what we are having of the continental, is 20 to 70 kilometers. Okay. We are having this one, and then it has another very important characteristics which we should remember, is that the oceanic crusts are heavier. They are having around like 3.2 g of density, and whereas the continental crusts are comparatively lighter, and it is around 2.7. Okay. The reason is that the oceanic crusts are comprised of heavier rocks. Okay. Mostly the basaltic rocks are comparatively heavier, whereas the continental crust are comprised of the material or the rocks which are made up of silica and magnesium. Okay. So, they are comparatively lighter as what we see in the oceanic crust. Okay. Of course, we are having further lighter ones which are extremely like comprised of what we call silica and aluminum. So, we call that as an SiAl, SiAl. Okay. So, silica and aluminum, mostly the granitic rocks. Okay. We will see in the, or we find in the continental crust, they are lighter. We also have the slightly heavier ones which we call SiMa, and mainly we are having the silica and then we are having the magnesium. Okay. And the contact between these two, or the boundary between these two, is been termed as Conrad discontinuity. Now, discontinuities were been identified by various seismologists and the geologists, and they were been named accordingly. Okay. So, this is the boundary between the lighter rocks and the heavier rocks within the continental crust. Okay. Whereas, here there is no such boundary which exists. Okay. And the oceanic crusts are comparatively thinner, but even though they are thinner, they are heavier as compared to the continental crust. Then if we move further down, then we are having the contact, that is the boundary between the lithosphere, or the top surface, the oceanic crust and all that, and the lithosphere we are talking about. Then we are having the boundary which is marked as an Moho discontinuity. Now, Moho discontinuity is like it separates the crust comprised of low density silicate rich in aluminum and potassium from the mantle. That is, the mantle is again the upper part. If you look at here, this part is the mantle completely, which comprised from here up to this part. Okay. This is the mantle part. Okay. So, it from mantle composed of silicate and higher density, which contains more magnesium and iron 1. Okay. So, this is the boundary between the Moho is the boundary between the crust and or we can say the lower part of the mantle here. Okay. And then we have another one which is a very important one, is termed as the asthenosphere. Okay. The asthenosphere is which occurs at the depth of 100 to 400 kilometers, and this layer is partially molten. Okay. This layer is responsible for generating convection currents, okay, or convection within the layer because of the heat flow, and this is responsible for the movement of the plates, okay, or the continental or the oceanic crust on the surface. Now, I hope you people might be knowing that this oceanic crust and the continental crust are moving, okay, they are not stable. So, they are having the relative motion with respect to one another, and they are not stable. Okay. So, asthenosphere is responsible for that, and then we are having mesosphere, we are having lower mantle, and then we have this one, that is the outer core is the liquid one. Okay. So, we will continue this in the next lecture. We will start with the interior of Earth. Okay.